Okay, we're going to work on some extra examples with you. I hope you've had time to practice a little bit on your own. Here we're given a right triangle that has one leg of length 5 and a hypotenuse of length 13. And what we want to do is find the sine, cosine, and tangent of all the angles in the triangle. Well, I hope you know that the master formula here is going to be SOHCAHTOA. That's the one we're going to use. But in order to use SOHCAHTOA, you have to know the lengths of all the sides of the triangle. Let me set up a variable for this length. So we need to solve x squared plus 5 squared is equal to 13 squared. So that's x squared plus 25 is 169. X squared is equal to 169 minus 25. That's 144. And so x equals 12. So that tells us our third side length. It looks like my triangle isn't really drawn to scale because, of course, 12 is a lot bigger than 5. But we can still do all the calculations here. So even if we didn't draw the triangle perfectly to scale, you can still figure out the calculations. Let me label the angles, theta and phi. And we'll look at theta first. Sine of theta, using SOHCAHTOA, is opposite over hypotenuse. So that's 12 is the opposite angle to theta, or the opposite side to theta. And the hypotenuse is 13. Cosine of theta is equal to adjacent, well, the side adjacent to theta is 5 over 13. And the tangent of theta is equal to the opposite over adjacent, so that's 12 over 5. Phi, sine of phi, let's do that one first, is equal to the opposite over hypotenuse. Well, the opposite side to phi is 5, and the hypotenuse is still 13. The cosine of phi is equal to the adjacent side. The side adjacent to phi is 12 over 13. And the tangent of phi is equal to the opposite over adjacent. Well, the opposite side of phi is 5, and the adjacent side is 12. And finally, let me label the right angle alpha. The sine of alpha, I'm not going to use SOHCAHTOA on this, but the sine of alpha is just, I remember, the sine of pi over 2 is 1. The cosine of alpha is the cosine of pi over 2, which is 0. And then the tangent of alpha, again, we haven't really learned about tangents yet, but it turns out that the tangent of a 90-degree angle, or the tangent of pi over 2, is undefined. So we'll learn why that's true when we get to studying the tangent function later on. So to recap here, everything came out of the master formula SOHCAHTOA. Memorize that word SOHCAHTOA, or memorize the phrase, "Some old horse caught another horse, taking oats away." That helps you remember how to figure out all these sines, cosines, and tangents once you know the lengths of the sides of a right angle.